Here's the next big important idea. If you have an area that you're trying to find under a curve, and part of that area is below the x-axis, you have to subtract those areas out. If I asked you to find the area of, for example, this trapezoid, the area is a positive number. But when we find that the area below a curve hangs below the x-axis, then when we compute, when we add up the different pieces of the area, we're going to subtract out pieces that lie below the x-axis. So watch this. To find this integral, this is the integral from -1 to 4 of f of x dx. This means find the area under the f of x curve, well, technically between the f of x curve and the x-axis, between x equals -1 and x equals 4. It's going to have two parts. This part here, this trapezoid, lies above the x-axis. So I'm going to find the area of that trapezoid, just using what I know from geometry. And this area down here lies below the x-axis. So after I find the area of that red trapezoid, I'm going to subtract it away from the area of the green trapezoid to get my final answer. So for me, that green trapezoid has, I can just use the formula for the area of a trapezoid. If you happen to break this up into a rectangle and two triangles, you'll get the same answer, and it's fine. Split this up any way you like. I'm going to think of this as a trapezoid. For me, the parallel sides have units 1, and 1 across the bottom is 3. So I'm going to find the average of 1 and 3 and multiply by the other dimension. In this case, that other dimension is the height. That trapezoid has a height of 2. And I'm going to subtract away the area of the red trapezoid. That red trapezoid, if you thought of that as a square plus a triangle, that's fine. You're going to get the right answer. But here, that's going to be, the two parallel sides are 1 and 2. I'm going to find the average of 1 and 2 and multiply by the other dimension. In this case, that's, again, the height. Here's a height of 1. So this tells me that the area under this curve, so the value of the integral is of 4, take away 3/2. So I'm going to write how I would write my final answer. I would say that the integral from -1 to 4 of f of x dx is 4 minus 3/2 is 5/2. Final answer. Okay, one last idea, because we're going to save the part with the calculator for when we're in class together. Our next job is to learn how to find the values of a bunch of different kinds of definite integrals. So we'll start off with one that's not too bad. I hope you'll see the connection between the geometry we've been practicing and how to find the area under this special kind of curve. If the curve, the function that I'm going to find the area under, is a constant, watch what happens. If I have my axes and I have some curve, f of x equals c, or in your function booklet it was f of x equals a. So some function that if I graph it, it just looks like a horizontal line. And I know that the equation for that horizontal line is y equals c. If I want to find the area under that curve between a and b, when I draw that area, it's easy to see. That area is going to be a rectangle. It has to be a rectangle. There's no getting around it. So how do I find the area of this rectangle? Well, I'm going to figure out the distance across the bottom, which is the difference between a and b, which I would get by subtracting b minus a. So that's the width of the rectangle. What's the height of the rectangle? Well, it's whatever this function value c is. And since it's a constant, it's never going to change, it's always going to be exactly c. So I have a height that never changes. My area is just going to be b minus a times c. And you can see that here we've written in this rule that you can memorize. You probably won't have to memorize it because you'll end up using it so much. If I want to find the area under a constant curve between a and b, the area is just the area of a rectangle. So the difference between a and b to give the width of the rectangle times the height of the rectangle, which is going to be whatever this function value is. So let's practice that. Here I've been asked to find the area under the curve y equals 5. Well, here's y equals 5. Y equals 5. Between x equals -2, and x equals 1. So you don't have to draw this picture anymore if you don't want to, or you don't have to memorize that formula up there if you don't want to. You could just draw the picture and understand. For me, this is going to evaluate is the area of this rectangle. So the rectangle that is 3 spaces wide with a height of 5. So 3 times 5, 15. And notice if I want to use this formula, that's going to be 5 is my C times 1 minus my A value, the left-hand side of my interval, -2. So 5 times 3, well, let me write it here. That definite interval is equal to 15. That is not an approximation, that's an exact value. The second one, similar idea, it's just I have a slightly more interesting constant function. If I want to find the area under the curve, y equals radical 2, y equals radical 2, my left limit is going to be radical 2. My right limit is going to be, what, radical 18? You can either draw a picture and find the area of that rectangle, or you can just use this formula, which is we're going to have radical 2, which is the function, the constant function in this case, times the difference between the A and the B value, so the distance across the rectangle, which is going to be radical 18, take away radical 2. I'm going to use the distributive property, so it's going to be the square root of 36 minus the square root of 4, which is 6 minus 2, which is final answer 4.